Hi everyone. So today's topic is diffusion models. As we all know that LLM models generate only one token at a time from left to right, but diffusion models can generate multiple tokens at a time. So we are going to see how they are able to do that and what are the advantages of using diffusion model. So first we just see how normal LLM models work, right? So when we see how they generate tokens, they generate token one at a time and from left to right. And in case of diffusion models, what is the difference is that we are using bidirectional attention, but in case of AR models, we used to have causal mask. So the token can only see the past tokens, but it cannot see the complete picture, right? So how diffusion models work, right? So we start with mass tokens, right? And then in each pass we create a draft sentence. Okay, so suppose we created some statement now, and out of every token we check what is the probability, and if it is higher than the threshold we keep the token, otherwise we again mask it. So we continue to revise our sentence until we get the final output, right? So this idea is taken from image diffusion, right? So there we reduce noise and we take multiple steps, and in the end we are able to get the final image. So here like when we are generating the complete sentence, there are no early commitments like in case of LLMs, where when we select a token it is fixed, we can't change it in future, right? But in case of diffusion models, since we are generating the whole sentence, so it is a open canvas for us. The issue with diffusion model is that we must have to decide the length initially, right? In case of LLM models, there is a concept of end of sequence token, so LLM decides by itself when to stop. But here in diffusion model we have this issue. So the training of diffusion model, in the training we mask some of the tokens present in the sentence, and the model learns to predict them. So here T signifies like from 0 to 1, and if the value is 0.3, it means that 30% of the tokens will be masked. So for different values of T, the model is trained so that it can predict the complete sentences by itself. So this was the same concept, right? We will only keep the confident ones and we will reject the ones which are having low confidence score, so we will mask them again. So with the problem with AR was that when we know that there is a relationship between A to B, but we struggle to find out what is the relationship from B to A, right? So for example, this statement is written, right? Paris is the capital of France, so trained in this direction, so it was trained from A to B. But if we ask the opposite, so the capital of France is, so it can struggle in the opposite direction because of the unidirectional attention, right? So since here we are creating complete sentences, so bidirectional context we are having, right? The issue which we were facing with diffusion model was that because of bidirectional attention we can't have KV cache, right? So also there was this limitation of providing the length initially. So to avoid that issue, what we have come up with, we come up with the concept of blocks. So we divide the sequence into multiple blocks. So in each block we can generate tokens parallelly, but one blocks is sequentially added after another block. So blocks are sequentially added, but the tokens inside one block are added in parallel. So this also solves the length problem, right? And we can use KV cache as well, because we are generating some part of it sequentially. Also, we can convert LLM model to diffusion model. So there is a 3-step process for this, like warm up, stable, and decay. So in the warm up step, we are keeping the block size as 1, so it behaves just like autoregressive model where one token is predicted at a time. And then we increase this number from 1 to 4 to 16, like that, until we are able to generate the complete sequence, right? Then we start again decreasing the block size, so that we can utilize KV cache and we can improve the performance. So initial model which was created was LLaDA 1.0, which was a 8 billion parameter model, and it was trained from scratch, right? But the LLaDA 2.0, which is a 100 billion parameter model, it is converted from the autoregressive model, right? So it is the first frontier scale diffusion LLM. So as we all know that in each pass we are able to generate more tokens in diffusion model. So this is like telling that only. When we come off with like advantages of using diffusion models, so there is bi-directional context at every step. Then there is much faster responses as compared to what LLMs can give in case of long outputs. And then we can also inherit knowledge, because we can convert LLM models to diffusion models, and it will avoid training the model completely from scratch. And since training requires millions of dollars, right? So we can save that cost. And also it is still evolving. With time we will see new diffusion models coming up. So autoregressive models like write in ink, so we can't change it, but diffusion models work in pencil, so we can keep on updating it and make it the sentence more better. So it can generate more coherent sentences as compared to what LLM can generate. So yeah, I think this was it in the video related to diffusion LLMs. See you in the next time.